So let's derive the law of cosines. For our example over here, what's the first thing we did? Dropped an altitude. Then I called this bit right here, I called this part x. So the second part would be still b minus x. Perfect. We're okay. Then I wrote h in terms of sine of a. And that hasn't changed. We agree? It's still going to be x sine, it's going to be c sine of a, because it's going to be opposite over hypotenuse. And then we wrote x in terms of cosine. So x is going to be c cosine of a. So that's the important step to deriving the formula, is working on the left-hand right triangle and establishing these two relationships. What did I do on the right-hand side? I used Pythagorean theorem. Right? So we have h squared plus b minus x squared equals a squared. H is equal to c sine of a. I'm going to substitute c cosine of a for x. Which is what we did for the second step. This becomes c squared sine squared a plus, I'm going to FOIL this, and we're going to get b squared minus 2bc cosine of a plus c squared cosine squared a equals a squared. I just FOIL it in my head, right? You're looking at me suspiciously. Okay, good. I'm going to bring the c squareds together. Factor out a c squared. This organization step here is in some ways, this is also a key, so you can actually think about this. Because what do we now know, Alexis? What do we now know sine squared a plus cosine squared a equals? What does this equal? 1. Perfect. C squared times 1 is c squared, and here's my formula, or a law. So this is the bit that you need to know. This is the why, or this is how I got it. How are we? So I want to go back and let's redo that last question with those numbers, and let's demonstrate that we're going to be okay. It's going to work. So here's the original question. And let's say I want to find angle A. Let's say I want to find angle A. Because that's important, because I can write the law of cosines three ways. I can write the law of cosines three ways. So let's say I'm focusing on angle A, which is how I've written the formula over there. So I have A squared, so 10 squared. Here, let me write it again. A squared is equal to B squared plus C squared minus 2BC cosine A. 10 squared is equal to, B is going to be 16. C in this question was 12. I'd write this example down. This is what you're actually going to do. I doubt you're going to do it this way anymore, unless you're doing like the house on the hill or something more complicated. 12 squared minus 2 times 16 times 12 times cosine A. Bless you. So I have 100, 256, 144, minus, what's 2 times 16 times 12? 364. If I bring the 256 and the 144 over to the other side, still negative 300. See how we're there? See how we're here already? We're back down to here. We're already here. You guys haven't had enough coffee. So obviously I'm here, and I'm now here, and I'm back to getting the answer. Okay, so you have law of cosines. What was my scenario in the beginning? It was side, side, side. Side, side, side. Because if I went sine of A over 10 equals sine of B over 16, I wouldn't be able to solve for either angle. Too many variables, right? Good? General thoughts, questions? If you're 70% in the ballpark with this, you're fine. Because obviously we'll come back Tuesday after the quiz, we'll do more examples on law of sines, we'll do a law of cosines examples, and I need to start the ambiguous case with you. Yeah.
Is this what's going to be on the
No.
quiz? Oh, okay.
No, it's, you know, with the let statements, the area, you know, you're doing geometric type trigonometry, maybe, you know, summer school on a hill. Cool. All right. I will see you Tuesday.